The farthest human-made object from Earth is NASA's Voyager 1 spacecraft, which has ventured into interstellar space. Imagine launching a spacecraft 45 years ago and having it continue its journey far beyond its intended limits, defying expectations and outlasting its planned mission. This is the astonishing reality of a groundbreaking NASA mission that is reshaping our understanding of space exploration. But what's even more remarkable is that this resilient spacecraft, now billions of miles away, still transmits data back to Earth using technology older than a cassette player. And that's not all. Launched in 1977, Voyager 1 has just made a discovery that has stunned the scientific community and captured global attention. What could this amazing find in the far reaches of space be? And what does it mean for us here on Earth? There was a key moment in history when two of the most amazing space missions ever launched ushered in the age of space exploration. It was thanks to the brilliant mind of Gary Flandreau of NASA's Jet Propulsion Laboratory that an ideal route was mapped out for a probe to reach the distant planets, Jupiter, Saturn, Uranus, and Neptune. With just a pencil and a 20th century engineering tool, Flandreau made a startling discovery. In the late 1970s and early 1980s, the four gas giants would be aligned in a unique cosmic configuration, creating a sort of celestial necklace with Earth. This method allows a spacecraft to gain speed by utilizing a planet's gravity, much like being pulled by an invisible rope. With these gravitational assists, a journey from Earth to Neptune that would typically take 30 years could be completed in just 12. However, there was a challenge. The necessary planetary alignment occurred only once every 176 years. Seizing this rare opportunity, NASA moved swiftly, launching two identical spacecraft, Voyager 1 and Voyager 2, just 15 days apart in the summer of 1977 to capitalize on this celestial event. Little did they know then that these twin explorers would break all records in the history of space missions. More than 45 years after their launch, the Voyager 1 and Voyager 2 spacecraft are still operational, sending back information daily from the edges of our solar system. These probes have become the farthest spacecraft in history, having traveled far beyond what was first imagined, which is impressive when you consider that their original mission was planned to last only 4 years. However, these interstellar pioneers had many surprises in store. At the start of their epic journeys, they gave us incredible close-up images of the moons of Jupiter and Saturn, revealing worlds far more active and dynamic than had been anticipated. Discoveries of active volcanoes and ice fields forever changed our understanding of these distant corners of the solar system. Voyager 2, in particular, was the first spacecraft to approach Uranus in 1986 and Neptune in 1989, becoming the only probe to have visited those planets, surprising scientists with astonishing discoveries in previously unexplored territories. More than 14 billion kilometers away from Earth, these probes, each about the size of a Volkswagen Beetle, have exceeded all expectations, continually pushing the limits of our understanding. The Voyager mission commenced with a gravity-assisted flyby of Venus, an unprecedented maneuver for any spacecraft en route to Mercury, solidifying their status as true pioneers. Their journey to Jupiter spanned 10 times the distance between Earth and Mercury, requiring them to navigate the treacherous asteroid belt, a challenge previously undertaken by the Pioneer 10 and 11 probes. Yet, the obstacles didn't stop there. With just 69 kilobytes of memory, a fraction of the capacity of a modern smartphone, the onboard computers had to rely on their own intelligence to manage the complexities of this extraordinary journey. Data collected by the Voyager instruments was stored on 8-track tape recorders before being transmitted to Earth via a transmitter that used just 20 to 23 watts, about the same power as a light bulb. The spacecraft were equipped with 12T-diameter satellite dishes to facilitate communications. They used light-speed radio to send and receive messages, but the increasing distance from Earth, an advance of 3 or 4 light seconds each day, presented major challenges. Despite these challenges, the Voyager probes have surpassed expectations, astonishing astronomers with surprising discoveries in the depths of interstellar space. Their journey has reshaped our understanding of the universe and transformed our perception of the unknown. Beyond our solar system lies the mysterious Oort cloud, a massive collection of comet-like objects bound by the sun's gravity, extending toward the nearest star. While the Voyagers continue their gradual approach to this distant region, their passage into interstellar space began when they crossed the heliopause, the boundary separating our solar system from the vast expanse beyond. Initially, this boundary was estimated to be about 50 astronomical units AU from Earth, and so it was decided to continue funding the mission even as the probes approached that milestone. However, crossing this boundary did not immediately detect a change in the environment, leaving scientists baffled. The passage into interstellar space was expected to be accompanied by an abrupt increase in the number of cosmic rays, high-energy particles traveling at nearly the speed of light, ejected by supernovae and other cosmic phenomena. However, most of the high-energy rays are reflected by the magnetic shield generated by the heliosphere, which protects our solar system from most external threats. As Voyager traveled into the interstellar medium, a region filled with ionized gases and shaped by nearby stars, the mission team closely tracked any shifts in the surrounding magnetic field. Scientists had expected the interstellar magnetic field to be oriented differently from that of the heliosphere. However, the Voyager probes detected no significant change. On August 25, 2012, Voyager 1 finally crossed the heliopause, sending back intriguing data that confirmed an anticipated rise in plasma density but showed no evidence of a shift in the magnetic field. This was unexpected, as researchers had predicted a noticeable change when transitioning from the solar-dominated magnetic field to one influenced by other stars. The findings sparked intense debate within the scientific community. If the magnetic field remained largely unchanged upon crossing the heliopause, what did this reveal about the interstellar medium and how our solar system interacts with its surroundings? Voyager 1, by entering this new region known as interstellar space, offered a direct window into a never-before-explored area, but it also raised more questions than it answered. One early theory suggested that the interstellar magnetic field might be aligned in an unexpected way with the solar field, creating a smooth transition rather than an abrupt cutoff. This would imply that the forces shaping our cosmic neighborhood are more complex than we had imagined. The data also revealed a noticeable increase in high-energy cosmic ray particles from outside the solar system, confirming that Voyager 1 had officially left the protective bubble of solar influence, known as the heliosphere. But the mystery remained. If there was no marked change in the magnetic field, how far was the probe really from a region completely dominated by the interstellar medium? Some scientists speculated that there might be a more extensive transition zone than anticipated, a region where the effects of the sun still interact subtly with the interstellar environment. Others suggested that the heliopause might not be a clearly defined boundary, but rather a fuzzy border that varies depending on factors such as the solar cycle or the pressure exerted by the interstellar medium. As Voyager 1 ventured beyond the heliopause, the data it sent back to Earth challenged long-standing beliefs. Observations of plasma density uncovered surprising variations, suggesting that interstellar space was not the uniform void once assumed. Instead of a featureless expanse, this immense region appeared to consist of plasma pockets, each exhibiting unique densities, temperatures, and energy levels. These discoveries left scientists perplexed, as existing models had predicted a relatively uniform interstellar medium, shaped over millennia by the steady influence of stellar winds and cosmic radiation. Voyager 1's instruments, however, told a different story. In just a week of observations, the probe recorded fluctuations in plasma density, indicating it was traversing regions with strikingly different properties, some dense and hot, others unexpectedly sparse and cold. The contrast was so pronounced that scientists began describing these areas as plasma clouds. Further analysis revealed that these clouds appeared to align with remnants of ancient supernovae, hinting that the interstellar medium may still carry the marks of cataclysmic stellar explosions from millions of years ago. Each of these pockets could serve as a relic, offering insights into the turbulent history of our galaxy.